So this is how you can actually apply this technique to solve many of your homework. Okay? So I would suggest you look back your homework number 4 again. Okay? You'll realize things is actually a lot easier than you thought. Okay? In our real life, okay, these are the 4 major state functions, right? But the quantities we can measure is actually P, V, T, alpha, kappa T, CV, CP. Yeah, and that's all. Okay, so typically when you encounter these questions, okay, you typically need to express with these variables. Okay? And maximum wear equation is actually designed for that purpose. Okay? So you can actually express certain things, certain relationship using the quantity you can actually measure. Okay? And what this really means is actually I want to know the volume dependence of the internal energy under constant temperature. Okay? And they will actually relate it to your pressure and temperature and the temperature dependence of the pressure under constant volume. Alright? So the equations tell you a lot of things, but your work is actually need to decode those equations. Okay, so the things will make sense to you. Otherwise, it's just equations. Okay? Okay, so in the I think we have still 15 minutes. So we're going to talk about the Gibbs free energy a little bit more, okay? So if you look at this plot, the Gibbs free energy is actually a function of pressure and temperature, right? So typically what people is going to ask, what is the temperature dependence of your free energy? What is the pressure dependence of your free energies? Okay, and these are the last 2 topics we are going to go through before your midterm. So the first thing is actually the pressure dependence. Okay? So when you see the pressure dependence, you should know, you should write down partial G, partial P at constant T. Okay? Because you know G is a function of P and T. Okay? If you want to know the pressure dependence, it has to be under constant temperature. Okay? And once you see the word dependence, that means you put that guy in the denominator. Alright? So partial G, partial P at constant T. And this is what? So what's that? Partial G, partial P at constant T. Okay, so we know dG is equals to what? dP and dt, right? Okay. So